Hello, Professor Willoughby, and welcome to Mysteries of the Sky. Today, we don't have a wonderful picture of the day, but we have our own picture of the day, as you can see, that's going to help you understand exactly what we're talking about. If you do not remember, my name is Rob Marshall, and I'm from Team 3.
I'm Jordan Parchman. I'm also from Team 3, front row every day.
And as you can see, like I said, we're talking about the phases of the moon. And Jordan here is going to tell you exactly what's going on with this picture, and I'm going to move my head out the way.
Okay, so with this picture, this is the Earth in the center. The sun is on this side, which is why if you look at the Earth and then all the small moons, it's always lit up on this side because that's the direction that the sunlight is coming. Each of these are the different phases of the moon that we've drawn. And what you're seeing with these smaller moons is your pathway or line of sight to the moon from each different position on Earth. So for example, if you're standing right here on Earth and the moon is here, this half of the moon is lit up as well as this half of the Earth. But really, if you're looking at it this way, then this is the view that you would get. So Rob's going to explain a few of the phases and then I'm going to show them through the drawings.
So basically what we know from the moon, just to understand exactly how we get these rotations or these phases, the moon rotates at the same speed as it orbits Earth. So in about 27 days, some like to say about 27.32 days, it takes the moon to go around the Earth. And we also know that the moon spins on its axis and has one full revolution. So that's why we see the same face of the moon, which is important to understand when we're seeing how the sun rays and also traveling around. We're always going to see that same face of the moon. For example, so we have the first quarter moon, which can also be used with the same principle as the third quarter moon. And what we would see is the moon being half lit or having a half moon. And that is because the moon is aligned at a 90-degree angle if we drew a picture to the Earth and the sun. Therefore, because of this 90-degree angle, we see approximately half of the light side or the dark side. But because we always see those revolutions and those axes always turning, we're always going to see the same face of the moon, which would be the light side. So Jordan's going to explain that in this picture.
Well, Rob kind of explained quite a bit of it, but like I said earlier, with the third quarter, you're getting the moon at a 90-degree angle between the sun and the Earth. And so if you're looking at the moon and it's positioned in this direction, half of it's lit up and you're looking dead in the middle, dead in the center of the moon, which is why you see half of the moon and not the other half. The same thing happens with the first quarter moon, except where it's just flip sides. So if this is the angle you're looking at Earth and it is directly in front of you and you are seeing exactly half of the lit up side because of the sun rays in this direction, and then you won't see the other half of the moon.
So knowing that we have different angles to the moon, we're going to see different portions of how much the moon is actually lit. So we can actually go to the waxing gibbous now, which we're traveling counterclockwise. And after the first quarter, the sun portion is still increasing, but it's more than half. So we would call that a waxing gibbous.
So basically what he's saying is that the view of the moon that you're getting from Earth, I'm going to draw a bigger picture. So obviously the moon is always half lit up, but the way that we're seeing it, the view that we're getting makes it look like this. And so this is the side that we don't see. So we're seeing this much. Like Rob said, it's more than half. The reason why we see it though is because, so if this is the moon, this is the sunlight coming towards it. The angle that we're actually seeing from Earth is this because it's not directly in front of us, and therefore that's why you can see right here, this is a lot of the lit up part, and there's just a small part that we're going to see that is not lit up, if that makes more sense.
Okay, next we have a full moon. And a full moon is what we would see is a totally lit moon. And that is because we're seeing, we're seeing the sun's rays directly on the moon. And of course, we can't see the other side of the dark side of the moon because of the revolutions and axis, as you'll hear me repeat over and over. But the light is continually decreasing or increasing from the waxing gibbous. Therefore, the next phase we'll see the full moon.
So with that, like I said, the half of the Earth is always lit up and half of the moon is always lit up. But in this case, the view that we're getting, so this is you on Earth, the view that you're getting of the moon, since it is always half lit up, to you, all you're seeing is this section right here, which is the fully lit up part. So it looks like you're seeing the entire moon, but obviously it's a sphere, so you're not seeing the other half. But that would explain why it appears to be a full moon, and that you're seeing the entire lit up moon because of the direction you're facing it. Since you're directly this way and the sunlight is also going this way, that's why you see everything lit up. And there should not be any dark spots.
So next we see the waning gibbous, and we can use the same principles of the sun rays as we would see from the waxing gibbous. Only in the waning gibbous, you're going to see this the moon become increasingly dark.
So, as Rob said with the waning gibbous, so if you're right here on Earth, and you're looking towards the moon this way, you're going to see the majority of it lit up, but you're going to start to see a little bit of darkness. So, your view like this would be, your view is going to look like this, and that's because the direction that you're facing, you are seeing, if you're here, you're going to see mostly lit up, but it's still dark, but like that. That's going to be your view, and so you're still seeing a little bit of darkness, but you're seeing mostly light. And so, again, that's you.
Then we've already talked about the third quarter moon and how we're seeing exactly half, except we're going to see the moon increasingly darker. And so we went over that with the first quarter moon. Mm-hmm. So now we're going to go over to the waning crescent. Forgot to label that one. And we can use the same principles as well that we used earlier, only we're going to see a different, darker moon.
So by this point, you can assume this is where you're on Earth, and this is the view that you're getting in the angle. You're going to see you're not going to see most of the moon. You're only going to see a small little section of it, which would result in the waning crescent, and so you're only getting a small sliver, and that's probably one of the most well-known phases of the moon is the crescent. That's the one that seems to be represented the most. So with your view, you are only seeing this section, and so it's more than half of it is dark to you. If this is you on Earth, and then you're just seeing a little bit of sliver of lightness.
So then, for our next phase, we'll see the solar moon, and the way I think about it was a solar new moon to help me on the first exam, but it happens when the moon aligns between the sun and the Earth, and the side of the moon that is facing us is not lit up by the sun. So it doesn't happen every month because the sun, moon, and Earth do not always directly align, and so it's pretty rare. But Jordan is just going to talk about that.
So if you are on Earth, right here, then you are on the side of Earth that is facing the sun and that is getting those sun rays and therefore the light. And so if the moon is in between the sun and your view of the Earth, this is the moon, and this is the side that the sun rays are coming to. And so this half is lit and this half isn't lit, but the only thing that you're seeing over here from Earth is the dark side. So really you're not seeing anything. And that's just because the light rays aren't going to shine on this side, not reflect or anything. You're not going to see any light on this side. So that's what It's called a new moon just because there's nothing there. So, yeah, and that would be the solar eclipse.
And last we would have the waxing crescent, which we would start to see a little bit more light and going back to the first quarter. So basically the phases will be completing itself.
So
we're starting back over.
You got bigger. Sorry. So if this is you on Earth, and these are the sun rays. So as depicted in this small picture, of course, only half of the moon is lit up, as always. But the view that you're going to get is going to look more like this. Oh, a little bit less. Sorry. So this is dark. And so you're going to see just a little bit of this light right here, but it's much less than half. And so that's how you end up seeing this view, and this is how it would look if you were looking in the night sky. So again, it's a crescent, but it's just on the opposite side.
Also, one of the last phases that we want to talk about would be a lunar eclipse, which occurs during the full moon. And it's when the Earth shadow is on the moon, which is only visible during the full moon. So I guess you can, what I failed to mention was in the full moon is also synonymously used as a lunar eclipse in some people's eyes. So I hope you enjoyed the video, and I hope that we did well, and I hope my big head wasn't in the way, but I hope you enjoy this.
Oh, I don't know how to use it.
Yep. And bye.